Okay, a couple of fractions calculations here. We've got a division and we've got a subtraction with mixed numbers. Now, you've probably heard of keep, change, flip, KFC, whatever. People don't particularly like that, but the reason that works, as it were, is for this reason. Okay, so if I did 10 divided by 2, now I'm writing 2 as a fraction. 2 as a fraction is 2 over 1, but 10 divided by 2 we all know is 5. 10 times a half is also 5, and so what we have there is, it's called the reciprocal. You're turning one upside down, you can do a division, but that shows it in numbers, doesn't it? Okay, so I'm going to do that. We get 3/7 times 14/9, multiply the top two, multiply the bottom two. They are both in the 21 times table. They're also in the 3s, they're also in the 7s, I realise that, but 21s gives me 2/3. Now, the reason I wanted to do that, just 21. Now, I just want to show you this. So if I actually, I'm really clever, I spot that, alright, 3 and 9 are in the same times table. Both in the 3s, aren't they? 3 goes into 3 once, 3 goes into 9 3 times. And I'll do a different colour. What colour shall I use? I'll use the yellow again. 7 and 14 both in the same times table, both in the 7s, aren't they? So I can divide those. I can simplify before I simplify. So here we go. And I just end up with 1 times 2, 2, 1 times 3, 3. You can do it either way, but ultimately the answer is 2/3. Okay, so equals 2/3. Now then, with the second one, I'm just going to change to blue. There we go. Can't add or subtract fractions until you find a common denominator. But when you've got mixed numbers, and the mixed numbers are like the 2 2/5 and 1 3/4, okay, it's easier to put them into top-heavy or improper fractions. Now, 2 2/5, okay, this is what 2 2/5 looks like as a picture. Okay, where are we? There. All right, and all right, they should all be the same size, these, but you'll understand that I can't actually draw them that well. So 2 2/5 looks something like this. I will use yellow again. So the 2, there's 1, 2, so there's a whole one. There's another whole one, and that's the 2. Okay, and then 2/5 is there. So how many have I got in total? Well, I've got 10, 12/5 minus. And the 1 3/4, I'll do different colour. So, well, what are we in quarters, aren't we? So there we go. So here we go. So we go 1, 2, there's the 1, coloured all of those in, and 3/4. How many quarters have I coloured in total? Well, there's 7 on there. Oops, wrong colour. There we go. So minus 7/4. Now I still can't add or subtract because I haven't got the same denominator. Now the denominator, okay, is going to be 20. Okay. Now I'm going to put them all over a big fraction like this. So 5 into 20 goes times 4. So I need to do 12 times 4. I need to multiply the top by what I multiplied the bottom by. So it's going to be 48. And then 4 goes into 25 times, so I need to multiply the 7 by 5, minus 35. And I end up with 48 minus 35, 13/20. Alright, so that is, I think, the easiest way of doing it. Obviously, you wouldn't normally draw out all the pictures, but I was trying to illustrate a point. Okay.